ओके, बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम। क्या हाल है आप अरूबा? ठीक है, खैरियत से हैं?
वालेकुम अस्सलाम। यस सर, अल्लाह का शुक्र।
आज का सेशन स्टार्ट करते हैं। सो टुडे लास्ट सेशन में हमने जो है वो एनालिसिस और डिज़ाइन प्रोसीजर जो है उसको स्टडी किया था, और इस तरीके से हमने एनालिसिस दोनों जो प्रोसीजर्स हैं उनकी एग्जांपल्स जो हैं वो की थी। आज हम हाफ एडर से स्टार्ट करेंगे, यानी हम डिज़ाइन जो प्रोसीजर है उसको, जो कॉम्बिनेशनल लॉजिक सर्किट्स हैं उनके जो स्टैंडर्ड कंपोनेंट्स हैं जैसे एडर है, उसको हम डिज़ाइन करना सीखेंगे। तो सबसे पहले जो है वो हम हाफ एडर की बात करेंगे। हाफ एडर का अगर मैं यहाँ एक छोटा सा सर्किट बना दूँ तो हाफ एडर जो सर्किट है इसके अंदर हमारे पास दो इनपुट्स हैं। चूँकि ये एक स्टैंडर्ड कंपोनेंट है तो दो इनपुट्स हैं और दो हमारे पास जो है वो आउटपुट्स हैं। अगर हम इनपुट्स को कहें कि ये x है और ये y है, और आउटपुट में हमारे पास ज़ाहिर है हम ऐड कर रहे हैं तो एक सम होगा और एक कैरी होगा। तो हमने एक सम उसको शॉर्ट फॉर्म में ले लिया है और एक कैरी। जब हम इसका ट्रुथ टेबल बनाएंगे तो ट्रुथ टेबल के दो हिस्से होते हैं, जिसमें एक हिस्सा जो है वो इनपुट पे मुश्तमिल होता है और एक हिस्सा जो है वो आउटपुट पे मुश्तमिल होता है। सो ऑन द इनपुट साइड वी टेक x and y because these are two inputs, and on output side we take the sum and the carry. Usually we write carry जो है उसको हम पहले लिखते हैं और सम को बाद में लिखते हैं। सो in x we write all in truth table we write all the combination of input variables. So we write 0 0 1, similarly 1 0 and 1 1. So all possible combination are there. Now we have to write the output. We know when we add two binary numbers, so we get a sum 0 and carry is also 0. So I write here sum is 0 and carry is 0, and when we add 0 and 1 in both cases we get sum 1 and carry 0. So sum 1 and carry 0 for these both cases. And in the case of 1 1 I get sum is 0 and carry is 1. ये हम बाइनरी एडिशन की बात कर रहे हैं। So from this table I can write the boolean expression. In the design procedure हम इसी तरीके से करते हैं कि डिज़ाइन प्रोसीजर में जो है वो सबसे पहले जो है प्रॉब्लम दी होती है, वी आर टू डिज़ाइन ए हाफ एडर विच कैन ऐड टू बाइनरी bits and generate a sum and carry. Then we assign the variables to the input and the output, binary variables, and then we make a truth table. Afterwards we write the expressions for this sum and carry. So first of all, carry, as it is only one for x y, तो हम आसानी से ये देख सकते हैं कि this is primarily the case of AND gate. So C can be generated by the output of the AND gate. So I can primarily write here that so I write an AND gate and make XY inputs. So X input and Y input, and then I write here the output is primarily a carry C. So this is a direct we can write because no need to simplify here. Just we know that this is a definition of AND gate, so we can write the C. So internally in half adder we have this circuit. Similarly on the sum side we can see this is the exclusive OR gate. So we can make an exclusive OR gate, and then we can primarily show that X and Y are the inputs and the output is the sum. So this design example is very simple, and we can primarily replace this half adder signal. So I just erase this truth table for a moment so that I can make these circuits inside. I make a copy of and just may move over here. I think I need to adjust as well. Okay, so inside this half adder, actually I have these two circuits, which is one is the AND gate, and the AND gate is actually connected to the C line, and similarly it is connected to the X line like this and Y line like this. So I now have these two lines. So Y is connected and also X is connected to this. Similarly, I have internally the exclusive OR gate, and this exclusive OR gate has a connection with the X as well as with the Y. So it has a connection with the Y and it is connected to this. So I should make connections here as well so that these look like that these are the connections. So this is the case in which I have an AND gate here. थोड़ा सा इसको अच्छा बनाना चाहिए था मुझे, but anyhow. So AND gate here internally and exclusive OR gate here. So this is the design of a half adder. So the students will join थोड़ा जो देर में join किया है, they can watch the recording. Now we are moving forward towards the full adder. यहाँ मैं सवाल पूछना चाहूँगा if any student if a student have any question. जी अरूबा, आपका कोई सवाल है आपके जहन में? Okay.
No, sir.
Any other student, Mustafa या नासिर?
सर
Have any question?
अस्सलाम वालेकुम।
वालेकुम अस्सलाम। जी नासिर, क्या हाल है, आप ठीक हैं?
अल्हम्दुलिल्लाह, अल्लाह का शुक्र है सर। थोड़ा रिपीट कर दें सर, मैंने थोड़ा
यही
लेट में
स्टेप जो
ज्वाइन
है
किया
ये
है।
नासिर, यही स्टेप जो है ये फुल एडर में भी रिपीट होंगे, तो डू नॉट नीड टू वरी, वी आर गोइंग टू रिपीट द अगेन द होल प्रोसीजर विद फुल एडर. ओके
ओके सर, ओके।
जी मुस्तफ़ा, आप कुछ कहना चाह रहे हैं?
No, sir.
थैंक यू बेटा. So now we are primarily moving towards the full adder, and in a full adder the circuit is for the full adder. मैं यहाँ इस सर्किट को बनाना चाहूँगा full adder. In full adder we have three inputs, and these three inputs work like this, that we have X, Y and carry in. This C in is primarily carry in, and similarly we have two outputs. One is primarily the sum and another is the carry out. So this is sum and this is carry out. So this is the case, and when we write a truth table, so in truth table we have three inputs and similarly we have two outputs. तो इसका ट्रूथ टेबल यहाँ बनाते हैं हम, फिर हमें उसको सिंप्लीफाई भी करना पड़ेगा. So we have the inputs and we have the outputs. So here we have inputs. I write carry input here, X and Y. And similarly, I write the carry output and similarly the sum. So in a truth table, we know that we have to write all the combinations. So I write here all the combinations. So of inputs, so 0, 0, and then 0. Then again, I have to write 0, 0, 1 because there are 3 variables. So 2 to the power 3, there are 8 combinations. So we know these things already. So we make sure all the combinations are there for the truth table. Input side. So I have to make 4 more lines for inputs. Now all the inputs are now ready. Now I have to write the output as well. So when I add 3 binary numbers which are 0, I get sum as 0 and carry as 0. Now when I add 3 binary numbers 0 plus 0 and 1, I get sum 1 and carry 0. ये simple binary addition है. तो इसके बाद similarly the case for 0 1 0, I get the same answer because two binary bits are 0 and one binary bit is 1. Now here I have 0 1 and 1. In this case I get sum 0 and carry 1. Just the case of the half adder, when I add two binary numbers which are 1, so I get sum 0 and carry 1. Similarly is the case here that I get carry 0 and sum 1 because in 3 bits I have only 1 here. Okay, so here I get the carry and the sum 0. Similarly is the case for this carry and sum 0. And in the final I get carry 1 and sum 1 because there are 3 binary bits 1 which are being added. So by this way, by simple binary addition, I make this truth table. Now I have to simplify it for the carry out and for the sum. तो इसके लिए मैं चाहूँगा कि 3 वेरिएबल मैप जो है उसकी मैं हेल्प ले लूँ. So I make a 3 variable map here. And then I take one variable C in on this side and X on this side and Y on this side. So C in on this side, then X, Y on that side. Because the composition of truth table is then very easy to know. For C0, because I am simplifying this for C0, so hopefully I get an expression for C0. So I know that I have to write here minterm 0, minterm 1, minterm 2, minterm 3, minterm 4, minterm 5, minterm 6, and minterm 7. So I start from here 0, 0, 0. I do not need to write 0, 0, and 0. I need to write only 1 here because 0, 1, 2, and 3. So in 4, I do not need to write anything, but in 5, 6, and 7, so I write here 5, 6, and 7. Now I need to simplify. If I can see on horizontal and vertical sides, I can make few pairs. Okay? So I make some pairs. I use different colors. For example, I use the red color for this one, this pair, and then green color for, let's say, this pair. Sorry, one step back. red color for this pair, and then green for this pair, and then blue for this pair. So I can write. So now I need to write the expressions, and for C0, because I am writing this for C0. So C0 is equal to, as this is C0 and 1, I can label it as well, so that it becomes easy for me to write the expression. And similarly on the top, remember to use the gray code. So 0, 0, 1, 1, 1, and 1, 0. So in this case, we can write easily. So for the red case, let me change the color to red. So for the red case, because C input changes 0 and 1, so I do not need to write it. And when I see this is 1, 1, so I can write XY here. Then plus. Now I move towards this green one, green pair. In green pair, I need to write C input because this is present here. And then I need to check from XY. So X is changing 0 and 1. So I do not need to write X. I only need to write Y. Okay. So for the sake, I write Y here. Okay. YCI. Okay. Where it's changing the color. Green. Okay. Then from the blue color. Now in blue color, I can see CI is there, and from the upper top, Y is absent because Y is 1 and 0, X is 1. So I write X and CI. So in this way, I write the expression for the carry out. So I can make a simple circuit with 3 AND gates and 1 OR gate. So I need 3 AND gate and 1 OR gate. So let me make those gates for me. So 3 color. I need to change to black. Okay, so I need to have 3 AND gates and 1 OR gate for the above circuit, and I connect these like this. And for the input, I have to write here XY input. So X and Y. Similarly, here is Y and carry in. And similarly, here I have the X and carry in. So this circuit, which I have designed here, that we have designed, generate the carry. So this circuit, when I take inside the full adder, will start generating the carry for me. Okay. So this is the design procedure for carry out. Now I will do it the same for the sum. लेकिन इससे पहले कि हम आगे जाएं, मैं चाहूँगा कि यहाँ कोई सवाल है तो आप पूछें। जी बेटा, if you have any question right now?
No,
नहीं
sir.
सर क्लियर है।
Thank you very much. Now we proceed to the sum, and in a similar fashion, I actually want to use a 3 variable map. So a 3 variable map I construct here. For S, and now I have to just write the values, okay, for S. So for 0 I do not need to write, I need to write 1 here, and then for 3 I need to write 1 here, 3 0 4 नहीं लिखी, 0 1 2 3 and 3 के बाद 4 यहाँ आएगा, okay 4 5 6 and 7, so 5 6 and 7 will come here. So as you can see, there is no combination we can make on the basis of horizontal and vertical. डायगोनल केस में नहीं बना सकते, ओके डायगोनल में अगर आप चाहें इसको इसके साथ मिलाना, नो इट्स नॉट, ओनली हॉरिजॉन्टल एंड वर्टिकल. So we cannot make any, so we can write here the expressions for S, that S is equal to I can write in min terms, for example sum of and internally I write 0 1 2 0 1 2 3 4 5 6 and 7. So even I can write it from here directly from truth table. Truth table से भी मैं लिख सकता हूँ, but because there is a simplification procedure, so I first use to simplify it, but unable to simplify it because there is no pairing. I one only single cell या single जो location है that exists. So I can also write it in the respective min-term formats. So I can derive from the truth table as well. But Ci and for Ci, because this is 1, so Ci will be prime, and similarly X and then X prime and Y. Okay, so X prime and Y. Then plus the second term is 1, so Ci prime X and Y prime. Okay, so Ci prime X and Y prime plus, and for this one I can write Ci X prime Y prime. Okay, just make some space here, okay, so that it can be. And the last expression is Ci xy, okay, Ci x and y, xy. Okay, fortunately we have a simplified expression for this one, and that is Ci exclusive or x exclusive or y. So that means I just have to make a exclusive OR gate to represent. Let me just hide the floating controls so that you can see the full window. Now I can go and make a 3 input exclusive OR gate. Okay, so this is an exclusive OR gate, and it has 3 inputs, 1 2 and 3. Okay, x y and carry in, and then it will start generating the sum. So you can make a 4 AND gates and then 1 OR gate to represent this combination, because internally जो exclusive OR होगा उसमें यही गेट बने हुए होंगे, but exclusive OR is just a simplified form of this circle. जी बेटा, यहाँ आपके जहन में है? Beta, if you have any question regarding this full adder design.
नहीं सर क्लियर है.
Okay, finally we have to actually, because this is a small circuit, so we can make this circuit inside, we can take this circuit inside, okay, inside this diagram. So we take this circuit inside the diagram to generate the carry out, and similarly we take this circuit inside the diagram so that it start generating those. I need to make some space here, so that I can show the inputs as well. So I have this circuit with the inputs 1, 2 and 3, and those inputs I have already written here. These are the inputs, X, Y and C, and similarly I have the outputs here. So just copy paste and just okay, this is how the full adder circuit is, the internal circuit of the full adder. I can make the connections, but I can write like this as well. It is sufficient. अब मैं इसको आपको दिखाना चाहूँगा कि किताब में ये कैसे है. किताब में जब आप देखेंगे तो you find the half adder. Okay, in a half adder circuit you find this the truth table, the input side and the output side, and then you primarily use the minterms, sum of product form. So as you can see, the carry is x y, and sum is x y complement plus x complement y from this line. S can be written as x complement y, and for this one x y complement, and we write it in the form of addition because it's a sum of product form. I can write in the simple form as well. C is a sum of 0, 1, 2 and 3, and S is a sum of 1 and 2. This is a short form, sum of product form. Okay, so anyway, this method से भी आप लिखेंगे, you will come up with these circuits. इसमें 2 AND गेट होंगे और एक OR गेट होगा. It will generate the sum, and then you have an AND gate which generate the carry. So if we replace this circuit with exclusive OR, because this represents the exclusive OR, we get another compact representation for the half adder circuit. So this is the half adder circuit. The inputs and the outputs. Internal circuit is this one. We are using the basic gates and exclusive OR gates. So this is about the half adder, and now we are moving towards the full adder. Okay, in a full adder case, we have a truth table like this, जो अभी हमने देखा. उसमें there are 3 inputs. इसका जो circuit है वो हमने बनाया था. So it is like this. We have the 3 inputs, x, y. So and 2 outputs. So we have, instead of writing carry in, it uses x, y, z, because it have to write all the combination, and similarly for sum and carry. So this is a full adder. Full adder in short form is FA. Okay, so this is the just addition and the carry, sum and carry. Then we use the three variable maps to simplify and then write the expression. So the procedure is that there is a three variable map for S, which come out to be there is no pairing, no pairing, single cell pairing only. So single single. That means 2 की power single. Power में चलेगी 2 की. And here we have three different pairs, and we get the carry as the. Once we have the Boolean expressions, it is easy to make the gate, and this is the circuit for sum, and this is for carry. And further, it is easy to simplify this circuit because it represents an exclusive OR circuit. So we can replace this with the exclusive OR. So in that case, we just need to show this with an exclusive OR gate with three inputs X, Y, and Z. So internal circuit is as shown. This is the internal circuit of exclusive OR gate. So these are the expressions. The book proof that the combination equal to exclusive OR of the three input variables, which is the same as the case of sum. So a compact representation is also possible if we use two half adders to make a full add. So the combination is, अगर आप इसको थोड़ा सा इस तरीके से देख लें, that we have a half adder and we have another half adder. So this is the half adder. And this is another half adder. So in half adder we have two inputs. So we have two inputs and we have like this. And then we need another gate which we need to combine here with this input. And that gate would be the OR gate, which would combine both carries to make the output carry and sum. Okay. So X, Y, Z. And carry, we call it carry in and we call it carry out. So by doing this, we can generate a full adder by using two half adders. So in digital logic design, it is common to use simple circuits to make a complex circuit. Usually these ICs are available, and these ICs are available in the simulation software as well. And this is the internal circuit. In some time, we prefer to use the basic circuits to make a circuit because sometimes logic is very easy. छोटी सी इसकी एक एग्जांपल कर लेते हैं. So जी आप लोग बोर तो नहीं हो रहे? जी नासिर बताइए.
जी सर हो रहे हैं.
चलें आपको एक जबरदस्त किस्म की जो है ना वो एग्जांपल करवाते हैं. ओके, तो नाश्ता कर चुके हैं आप लोग या नहीं?
कर चुके हैं सर.
ओके, So let's say we are at a primarily at some party, and that party is based on three themes, and these three themes are present on, यानी तीन तीन डिश की पार्टी है ये, ठीक है. And on the table and there is also another table. So this is the table 1 and this is the table 2 and this is the table 3. और ये वो टेबल है जहाँ जो है वो इसको कहते हैं गार्बेज टेबल. ओके, गार्बेज टेबल ऐसे मेरे जहन में आया. सो व्हाट वी डिड, वी प्राइमरली टेक, जैसे ये आप कुछ चीज़ खरीदते हैं ना तो वो एक छोटा सा उसके पास स्केल होता है ना, वेइंग स्केल होता है वो. सो वी यूज ए सेल, ए लोड सेल to generate the electric signal, and similarly we have a load cell here which generate another electric signal, and we have a load cell here and which generate another electric signal. So we have three electric signals, T1, T2 and T3. So we need to primarily make an alarm for the kitchen. Kitchen जो है, अगर किसी एक जगह पे जो है वो जो सर्विंग है वो कम पड़ रही है, जैसे फॉर एग्जांपल इस टेबल पे जो है वो 10 सर्विंग रखी हुई हैं और अब 3 रह गई या 2 रह गई, अब इसको फिल करने की ज़रूरत है. तो जैसे ही सर्विंग कम होती है तो वी नीड टू जनरेट एन अलार्म फॉर ए सर्विंग जो कि कम हो जाती है, ताकि, और वी आल्सो नीड किचन टू नो कि कौन सी जगह की सर्विंग जो है वो चाहिए. जैसे फॉर एग्जांपल एक अलार्म है, अलार्म नीड्स टू रिंग एंड आल्सो इट प्रोवाइड्स द लोकेशन ऑफ द टेबल जहाँ जो है वो सर्विंग कम पड़ गई. ठीक है. नो वी नीड टू डिफाइन ए सिंपल, एक छोटा सा एक सोल्यूशन है. एक ऐसी जगह पे जहाँ 3 जो है वो सर्विंग्स हो रही हैं, यानी 3 डिश पार्टी है ये, और लोग जो है उनको कहा गया है कि वो खाना ले लें यहाँ से, और खाना खाने के बाद जब वो अपनी डिश वगैरह रखें तो वो इन्हीं टेबल्स पे मत रखें बल्कि एक गार्बेज टेबल पर रखें. तो जब वो यहाँ से खाना लेंगे, लेट से एक जगह पे जो है वो बिरयानी है और एक जगह पे जो है वो सलाद है और एक जगह पे जो है वो स्वीट डिश है, तो इस तरीके से हम सोच सकते हैं. तो वेन एवर ए थ्रेशोल्ड इज रीच्ड, सो एन अलार्म विल बी जनरेटेड, के जो है वो, और अलार्म विल बी जनरेटेड फॉर द, एंड वी आल्सो ए लोकेशन इज इंडिकेटेड ऑफ द किचन. तो किचन के अंदर हमारे पास 4 चीजें हैं. ओके, इन किचन we have 4. One is the alarm and another is, एक मिनट कोई साहब उनको भी इन कर लेते हैं, फैसल आ गए. ओके, an alarm, okay, one LED for T1, one LED and one LED for T3. Okay, so for alarm case, so we start with writing all the inputs, and similarly 0, 0, 1. Okay, so T3 has the signal, so the alarm should ring for T3. Okay, 0, 1, 0. Okay, so there is a problem with the serving with T2, so alarm should ring, and then we can write 1, 0, 0. So there is the alarm for T1, so alarm should ring, and that is the case for the alarm. वी डू नॉट नीड टू टेक अदर इनपुट्स, वो सब इसके लिए अलार्म के लिए जो है वो डोंट केयर होंगी। डोंट केयर से मुराद ये है कि अलार्म शुड रिंग फॉर एटलीस्ट दीज 3 इनपुट्स, ओके, फॉर T1, for T2 and for T3. So this is the case we can solve the primarily alarm. Now for LEDs to ring, we have to have some more outputs here, okay. So for location, let's see the input 1 is taken care of, and then the location 2 is taken care of here, and then location 3 is taken care of here. So if there is no alarm from the tables, we have all zeros. But when there is a table 3 rings, so the location 3 says, okay, there is a problem and you have to provide serving for table number 3. Okay, and there is no primarily case for here. Okay. Similarly, we go on and we see here there is a problem for T2. And similarly, we have a problem for T and 0 and 0 and 0. Okay, we can go on. अभी ये सेशन हमारा कंप्लीट हो जाएगा, then we start with the same example after about 5 to 10 minutes. Okay, मैं आपको मैसेज करूँगा। अभी तकरीबन टाइम कंप्लीट हो गया इस सेशन का। नेक्स्ट सेशन विल स्टार्ट आफ्टर 5 to 10 minutes.